Hello, this is Ms. Powers, and I am going to go over the notes for least common multiple, or LCM. If you're in your digital notebook, it's the GCF LCM virtual notebook, and this is where we're going to start today. If you have not drag and dropped your fill in the blanks, you're going to want to go ahead and just pause this screen so that you can fill these notes in if you don't get done by the time I go through the notes. So least common multiple is just the smallest multiple that two or more numbers have in common. And multiples are what you get when you skip count by a number. So in your mind, if you'll just kind of replace multiple with skip count, I think it's going to make more sense to you. Just kind of think of it as skip counting, okay? So to find the least common multiple, we're going to do the same procedures that we did yesterday for greatest common factor, because greatest common factor and least common multiple are like multiplication and division. They're just the kind of counterparts of each other as far as finding common denominators is concerned, or if you're doing certain word problems where you're trying to find a common number for a set of numbers, a factor or a multiple. So you can make a factor list like we did yesterday, or you can use birthday cake. I have also figured out a third way to work through it that I did with some people that needed some extra help, and they seemed to really like it. So I'm going to show you that way as well. So for least common multiple, to make a factor list, you're still going to see if your smaller number is a factor of your larger number, but I just reworded that today and said you're going to look to see if the larger number is a multiple of the smaller number, because if the smaller number is a factor of the larger number, that means you can multiply it by something to get that larger number. That also means that the larger number is a multiple of that smaller number, because a multiple is kind of like a product. You can think of it like a product. Okay, so factors are the numbers you multiply together to get another number. Multiples are like the answer to a multiplication problem. They're like a product. So if the relationship is there and that smaller number is a factor of the larger number, that larger number is your LCM. Okay, if it's not, then you're just going to want to list multiples of your larger number until you list a number that's also a multiple of your smaller number. That's going to be your LCM. To do birthday cake, you're going to do the exact same procedure that you did yesterday. You're going to list the factors side by side, factor out any common factor, keep going till the only common factor is 1, but then you're going to multiply all the common factors. And I put the prime forms of the original numbers. They may not be prime, but you're going to just use the final forms of the original numbers. So I do need to fix that in the notes, and I'm sorry about that. So they're not prime factors. They're just the final forms of the original numbers that you have. Okay, so I will fix that for next time. So what we're going to do now is we're going to look at some examples for least common multiple. Okay, so what we're looking at is we're looking to see, is 3 a factor of 4, or is 4 a multiple of 3? So could I multiply 3 by some number and get 4? And that is not the case. So that means that I need to list multiples or skip count by 4 to find something that 3 will go into also. Now, what I was doing earlier with somebody was I was just listing the first 5 multiples of both numbers and then looking to see if they had anything in common on the list. So I'm going to do that for this first one here. So I've got 3 and I've got 4, and I'm just going to skip count the first 5 multiples. So I'm going to do 3, 6, 9, 12, 15. 1, 2, 3, 4, 5. And then I'm going to do 4, 8, 12, 16, 20. So I have the first 5 multiples of both numbers. So I've taken care of the multiple part. So now I'm going to look for multiples that they have in common. And I'm just going to highlight any numbers that they have in common on these 2 lists. And I see no 3, no 6, no 9. Okay, so I've got a 12 on both lists. No 15, no 16, no 20. So I've taken care of common, and because I only have one choice, this has to be my least common multiple. 12, okay? Now, the other thing I could have done is just have listed the multiples of 4, my larger number, and at each level or stage, this is stage 1, 4 times 1, this is stage 2, 4 times 2, this is stage 3, 4 times 3. At each stage, I could have just gone back and said, does 3 go into 4 evenly? No. Does 3 go into 8 evenly? No. Does 3 go into 12 evenly? Yes. That's my smallest multiple that these two numbers have in common, okay? So that's kind of how you do this. If I were you, I would pause the video and try working on it myself and then playing the video and checking myself. So I'll remind you to do that a couple more times during the video. I just want to show you what this would look like with birthday cake. We would put 3 and 4 next to each other, and we go ahead and want to divide that out. Now, yesterday we would have found, we didn't do one like this yesterday, but yesterday we would have found that the only common factor that these two numbers have in common, the only thing that divides into both of them evenly is 1. And when I divide each of these by 1, I'm left with what I started with. And this is where you can see you don't always end up with prime numbers here because 4 is composite. So I should have just said the final forms. But 3 and 4 are the final forms of these numbers. I cannot factor anything out other than 1. What you do with birthday cake to find the GCF is you just pick anything you factored out. So the GCF here is 1. But to find least common multiple, you have to grab everything that's inside the L. L for LCM. You grab everything inside the L and you multiply it together. So 1 times 3 is 3, 3 times 4 is 12, which is what we found when we made the list above. All right. So let's keep going. Let's do 7 and 13. If you think you're already ready to do it on your own, pause it and try it. If you're not, you can follow through with me. So I'm going to start with my factor list. And before I do that, I'm just going to make sure, does 7 go into 13 evenly? Is 13 a multiple of 7? And it's not, because 14 is a multiple of 7, and there's not a 7 between 13 and 14. So I'm going to make a factor list. So first I'm going to skip count by 7, and I always start with 5. It's very arbitrary and random. Sometimes it works. Most of the time it works. Sometimes it doesn't, but we'll see. So I'm going to do 7, 14, 21, 28, 35. I've got 1, 2, 3, 4, 5. And you kind of know when you've done 5 because you'll get to whatever that number times 5 is, and it'll have a 5 or a 0 at the end. So now this is a little bit harder. I got to skip count 5 times by 13. So I'm going to do 13, 26, 39, and then 39, 49, 52, and then 52, 62, 65. Okay, so I'm going to stop. I've got 5 multiples of each numbers, and I'm going to look and see if I have anything in common. So I've got no, 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 no. So none of these are common multiples. So I'm going to do 2 more, and let me tell you why. Because this factor is 7, 5, 6, 7. If I do 2 more on each side, I will have the product of 7 and 13, and I never have to go higher than the product of 7 and 13 to find my least common multiple, because that's what they would be if I multiplied them together. All right. So over here, I'm going to just do 2 more, 35, and then it's going to be 42, and then 49. And then over here, I'm going to do 65, 75, 78, 78, 88, 90, 1. And this is, in fact, this is times 1, times 2, times 3, times 4, times 5, times 6. This is, in fact, times 7. So that means that 7 will go into 91 evenly. Now, I still don't have a match, so I can keep going over here until I get a match. So it would be 49, and then it would be 56. And then it would be 63, and then 70, and then 77, and then 84, and then 91, and I would get my match. Okay, but you need to kind of just be mindful as you're starting to do this that when you get to the product of these two numbers, if that's your first match, your first common multiple, then that is also your least common multiple. So for this problem, it's 91. Okay, now I'm going to do birthday cake again. Let me highlight these real quick so they all look the same. 91 and 91. I'm going to do birthday cake again for this one because I want you to see this pattern emerge. I'm going to do 7 and 13, and I'm going to divide them by their common factor. Well, if you think about this for a minute, you'll realize just like 3 and 4, 7 and 13 only have a 1 in common. I forgot to put my candle over here. That's one of my favorite parts. Only have a 1 in common. So when I divide 7 by 1, I get 7. And when I divide 13 by 1, I get 13. And I can't go anywhere else with this. Now, my GCF is still 1. It's the only common factor of 7 and 13. And when I go to make my L for my LCM, I'm going to multiply together everything in the L. I'm going to get 1 times 7, which is 7, and 7 times 13, which is 91. Okay, so that's my LCM. So what I hope that you see here is that there's this pattern that when the greatest common factor of two numbers is 1, that the LCM is the product of those two numbers. 3 times 4, 12. 7 times 13, 91. So when the GCF is 1, the only factor they share in common is 1, the LCM is their product. So let's look at this next one and see if that holds true and if we've really figured something out here. Again, pause if you are catching on and then play and check your answer with me as I go through the problem. So 4 and 25, are they a factor or a multiple of each other? They are not, because 5 times 5 is 25, 4 times 6 is 24, 4 times 7 is 28. So this is not a relationship that is a factor multiple relationship. So we're going to make our multiples list. We're going to skip count. So we're going to do 5 because that's what I always start with. So I'm going to do 4, 8, 12, 16, 20, and I already did that over here. And then I'm going to do 25, 50, 75, 100, 125, and this is just like money, 25 cents, 50 cents, 75 cents, $1, $1.25. So that's my multiples. So now I'm going to look for common multiples. So I'm looking over here and I'm looking to see if these have anything in common, and they don't. But then I'm going to ask myself, does 4 go into any of these numbers evenly here? If I keep skip counting by 4, am I going to hit 50, 75, 100, 125? So I'm thinking this through. If I skip count by 4s, am I going to hit 50? Well, I'm not, because 4 times 10 would be 40. 11 would be 44, 12 would be 48, 13 would be 52, so 50 wouldn't work. Is 4 going to go into 75 evenly? 4 goes into 7 once with 3 left over. 4 is not going to go into 35 evenly. Does 4 go into 100 evenly? And you should know there's 4 quarters and $1, so yes, that's going to work. Now, you could have kept going, 5 more, 5 more, 5 more, but listing out 25 factors is going to be a lot of factors for you, okay? And you should remember, this is times 1, this is times 2, this is times 3, this is times 4. Once I hit times 4, I've got the product of 4 and 25, and that has to be a number that 4 and 25 divide into evenly. So my least common multiple for 4 and for 25 is going to be 100. Now let's see if this holds true, what we learned before. Does 4 and 25 have a factor other than 1? And I just want you to think about that. What goes into 4 and 25 evenly besides 1? And you're going to realize that this one is just like the last two that we did. The only common factor is 1. And so when we went to find the least common multiple, we were just basically doing 1 times 4, which is 4, 4 times 25, which is 100, and the GCF is in fact 1. So anytime your greatest common factor is 1, you can just go ahead and multiply those two numbers together if you're also trying to find the LCM, or if you're trying to find the LCM. All right, last problem, factor list. We're looking to see what the relationship is between 5 and 30. Is 5 a factor of 30? And hopefully you're realizing that in fact, 5 times 6 is 30. So 5 is a factor of 30, and 30 is a multiple of 5. And if 30 is a multiple of 5, then 30 has to be the least common multiple. And if we do birthday cake, we will see, we'll put 5 and 30, and we're going to factor out of 5. 5 divided by 5 is 1. 30 divided by 5 is 6. 1 and 6 have no other common factor than 1. So we would take our L, we would multiply everything together, and we would find that our GCF, or our greatest common factor, is 5. And our LCM is 5 times 1 times 6, which is 30. Okay? All right. I'm going to clear this out. And we are going to go to LCM word problems, which is the next slide. I think I've mixed up the order of my slides. My arrow is not working either. Okay, so this is a drag and drop slide also, and if you need to, you can just pause the video to drag and drop your stuff over. But basically the situations you're gonna see that are gonna let you know you have a least common multiple problem are, it may ask you to find the least common multiple. Sorry about this. It may ask you to find the least common multiple. It may ask you when 2 or more things are gonna happen again. It may ask you when 2 or more things are going to happen at the same time, or multiple things are going to happen at the same time, or it might ask you to find the least, smallest, or minimum. There's one other that needs to be on here, and that is that you need the same amount of multiple things. You need the same amount of multiple things. That's also something that could happen. So this situation says Dana is planning a party. She can purchase napkins in packages of 50, plates in packages of 30, and cups in packages of 25. How many of each does she need to have the same amount of each item? So the plates, and I'm just going to put, the napkins, I'm just going to put it in for napkins, come in packs of 50. The plates come in packs of 30, and the cups come in packs of 25. And I need to know how many of each does she need. So I need to know how many packs of napkins, how many packs of 30 plates, how many packs of 25 cups to have the same amount. This same amount right here is the situation that lets you know that you need 50, 30, and 25 to all end up being the same number, okay? You need them to all be the same amount because you want to have the same number of napkins, plates, and cups. So if that's the case, we can't split packs, which means we're going to need multiple packs, okay? We need them all to be the same amount, which is common, and we don't want any more than them to just be an equal amount. So we're going to find the least. So this is a least common multiple problem. It's got multiples. They have to be in common. We want the smallest one. So we have 3 numbers here, but this doesn't change anything. We still just want to list out multiples for the 3 numbers. So I'm going to start with 50, and I'm going to go 50, 100, 150, 200, 250. 1, 2, 3, 4, 5. Now I'm going to do 30. 30, 60, 90, 120, 150, 1, 2, 3, 4, 5, 25, 50, 75, 100, 125, 1, 2, 3, 4, 5. Okay, so now I'm going to look for common multiple. So I've got, what do I have? So I've got a 50 here and a 50 here, but I don't have a 50 here. And there's not going to be a 50 here. So that's not going to work. Let's keep going. I've got a 150 here and a 150 here, but I don't have a 150 here. But 25 is actually, in fact, its next multiple is going to be 150. So 150 is going to be my LCM for my napkins. I can get 150 napkins, I can get 150 plates, and I can get 150 cups. So now though I have to make sure I answer the question, how many packs of each? How many napkin packs make 150? Well, there's 50 in a pack. And if I need 150, that means I need 50, 100, 150. I need 3 packages of napkins. And for the plates, there's 30 in a package. So I'm going to need 30, 60, 90, 120, 150. I'm going to need 5 packages. And for cups, there's 25 in a pack. So I'm going to need 25, 50, 75, 100, 125, 150. I'm going to need 6 packages of cups. And that is the answer to this question. All right. Your job now is to answer these 4 questions on your Google slide and type the answers into the boxes that I have provided for you. You're going to read your question and you are going to just fill the answer in by typing it in. So for this one, you're finding the GCF and the LCM of 9 and 6, and I want you to type the answers in these boxes. Here, you're going to put a name. Here, you're going to give me packages of buns and hot dogs. And here, you're going to tell me what time these guys are going to pack these boxes at the same time. So I will be looking for that in your Google slideshow. Thank you for being here, watching my video, and we will keep working on this when we get face-to-face next week. I will see you tomorrow. Bye.